rectangular cards whose dimensions are given as 2 inches by 3 inches are cut from a larger rectangular sheet whose dimensions are 2 feet by 3 feet. What is the maximum number of cards that can be cut from the sheet? So let's say this is the rectangular sheet that is given to us. The length of the sheet is 3 feet and the breadth is 2 feet. Since the length and the breadth of each rectangular card is given in inches, let's be consistent with our units. So let's convert these feet into inches. Because 1 feet is equivalent to 12 inches, the length of the rectangular sheet, which is 3 feet, this length in inches would be 3 times 12 or 36 inches. So the length is 3 feet or 36 inches. The breadth of the rectangular sheet, which is 2 feet, would be 2 times 12 in inches. So this would be 24 inches. So let's imagine that we start with this rectangular sheet and we take a pair of scissors and we start cutting out these smaller rectangular cards out of the larger rectangular sheet. And what we want to find out is what is the maximum number of cards that we can cut from the sheet. So if we want to maximize the number of cards that we can cut from the sheet, then we have to make sure that we are wasting as little of the sheet as possible. There should be we should be minimizing the amount of paper that we are wasting. So preferably we should try to cut out or carve out these cards in a way that we are not wasting any paper. So let's try the simplest possible way of carving out these cards or cutting out these cards. Let's say we start cutting out the first card like this. So this length is 3 inches and this length is 2 inches. So this length is 3 inches and this length is 2 inches. Let's say the next card that we cut out would be here. The next one would be like this and so on. So if we continue this process to the right, we will soon hit this boundary. But the question is whether we will hit this boundary exactly or whether the last rectangular card that we carve out would end slightly before this edge of the sheet. If the last card that we are carving out ends before this edge, that means there is not enough space beyond that point to carve out a full card, then we would be wasting some paper at the end. So let's just see whether that will happen or whether the whole process would run smoothly all the way till the very end. Because the total length of the sheet is 36 inches and the length of each individual card is 3 inches, if we divide 36 by 3, we will get the number of such cards which can fit along the length of this sheet. So this answer is a whole number, it's 12. So this means that the last card that we carve out will look like this. Its length will be 3 inches and the width as usual will be 2 inches. So we can exactly carve out 12 cards along the length of this sheet. Now once we are done with this process, We proceed to the next row where we again start carving out these cards one by one like this. And we know that the process will again proceed smoothly all the way till the very end. We repeat this along a third row and so on. Now the question is, if we keep doing this, the sheet that will be left will become narrower and narrower. So where will this process end? One possibility is that as we keep carving out 2 inches successively down the width of this sheet, at the very end we might end up with our last row of cards like this, and then the remaining width could be too narrow for us to fit one whole card. So that's one possibility. The other possibility is that this process could proceed smoothly all the way till the very end. That means the last card or the last row of cards would look like this. And in this case, there would be absolutely no wastage of paper. We would have used up the entire sheet to form our rectangular cards. So which of these two possibilities would happen? Well, we have to find out whether there would be an exact number of 2-inch pieces that would fit along the width of this larger sheet. So the total width of the rectangular sheet is 2 feet or 24 inches, and the width of an individual rectangular card is 2 inches. So if we were to divide 24 by 2, again we get an exact whole number, 12. This means we can fit exactly 12 rows of rectangular cards along the width of the rectangular sheet. So we can cut out 12 rows of rectangular cards, each row having 12 cards out of the original rectangular sheet. So the total number of cards that can be carved out would be the number of rows of cards, which would be 12, multiplied by the number of cards along each row, which is also 12. So this product is 144, and we have wasted no paper in this process. There is no leftover, there are no leftover pieces of paper after this cutting process is over. If the sheet that we had been originally given was slightly more longer than 3 feet, then in such a way that after reaching this point it was impossible to cut out another rectangular card, then this narrow strip that you see here would have been left over at the end of this process. So we can't just take the area of the whole rectangular sheet and divide it by the area of an individual rectangular card to compute how many such cards can be cut out from the sheet, because you can imagine having a narrow band of paper left over at the end, either here or even here, in such a way that you cannot cut out a rectangular card from this narrow band, but the band is long enough that the total area of the band by itself is more than the area of an individual rectangular card. So in terms of the total area, maybe the area of this rectangular band is more than the area of a rectangular card, an individual rectangular card, but still you can't really cut out an individual card from this narrow band unless you were to cut this into small pieces and then glue them together to form a rectangular card. But that's not given in the problem. You're asked to carve out these rectangular cards exactly without really cutting and pasting different pieces together. So that's why this is the way in which you would go about solving this problem. So the answer is 144.